Suppose your favorite AM radio station broadcasts at a frequency of 1150 kilohertz. What is the wavelength in centimeters of the radiation from the station? We are asked to do a conversion between frequency in kilohertz to wavelengths in centimeters. We have this equation where the speed of light is equal to wavelength times frequency. And because the speed of light is a constant, if we're given one, in this case we're given frequency, we can solve for the other, wavelength. Alright, so let's isolate wavelength, which is represented by lambda here. We can do that by dividing through by frequency, which is represented by nu. And we get lambda is equal to c over nu. Let's plug in what we know. Speed of light is given to you on your formula sheet is 2.998 times 10 to the 8 meters per second. Now hertz we don't want to put directly in the denominator because we want to match that up with seconds, and we're given kilohertz. So let's do a conversion factor here off to the side to turn this into per seconds so we can cancel out with the seconds there. Alright, so we're given 1150 kilohertz. 1150 kilohertz. Let's get rid of kilohertz, get rid of that. So we need a conversion factor with kilohertz on the bottom and hertz on the top. Alright, so we know there's 1,000 of the base units in a kilo of that base unit. Kilohertz cancels out. Now let's turn this into, this is a Z by the way, sorry, looks like a 2. Alright, so let's turn that into seconds, units of cycles or wavelengths per second. Alright, so we're going to put hertz, we're going to get rid of that. Put that across the conversion factor in the denominator. And a hertz is also the same thing as per second. And these are just one-to-one conversion factors. We're going to get, let's move this 3 more times, add 3 more zeros to this. 1, 2, 3, 1, 1, 5, 0, and then 0, 0, 0 per second. Or 1,150,000 hertz. Turn that into a scientific notation, and that'll fit a little nicer into our dimensional analysis, which is pretty much what we're doing. Let's get the sig figs right. The first 3 digits are significant, that last 0 is not. We got 1.15, those are my sig figs. 1, 2, 3, 4, 5, 6 times we move it over, so it's times 10 to the 6 per second. Now we can reciprocate this to the top. Either way, those are gone. We're finally in units of length. We're going to measure wavelength. So now we have meters. We need to turn that into, we're going to turn that into centimeters. So we need one more conversion factor to get rid of meters and end up with centimeters. So there's 100 centimeters in a meter. Cancel, cancel. We're finally left with the desired units, which is centimeters. Now we can take our calculators out to finish up the problem. 2.998 times 10 to the 8 divided by 1.15 times 10 to the 6 times 100. So our answer is we need 3 significant figures. This conversion factor has unlimited sig figs, the centimeters to meters, they all do. The conversion factors do, the ones we're using. So we need 3 sig figs. So the 2, the 6, and we'll round that 0 to the 1 to a 1. 2.61 times 10 to the, how many times we move that decimal? 1, 2, 3, 4 times. 4 times. So our final answer is 2.61 times 10 to the 4 centimeters. Check our answer one more time. 2.61 times 10 to the 4.